Guys, how's it going? My name is Ben Schaefer. At the end of taking RIT's MCET 211, which is our plastics and polymers class, for our last project we had to determine the best material to use for a travel coffee mug. That was at the determination of our individual group. Several tests we did were the impact test, the tensile test, and the heat deflection test to best determine the material to use. The first one I'll go through here is the impact test. I will go through broaching the two different materials that we chose, which were polycarbonate and ABS. And then from there, do the actual test, go through the steps, and then we'll go through the tensile test. So to appropriately broach, you take your material, put it inside the broacher, do not keep your hands near it. Get it as centered as possible. You're going to have a tick mark on the part where it's centered. Just bring it down, make sure you're holding it steady so the part doesn't fly everywhere. Alright, to deburr the part, you can either just take your hands and kind of get it out of the way. Sometimes I'll flip the part around and do it the same way, just on the other side to get both views. So this clear part is the polycarb. We have pre-broach samples here. This is now our impact tester. You go ahead and you measure the width and the thickness of each part. You're going to go ahead and enter that into your machine. You have your width, thickness, and the temperature of the conditions that you're running through. So once all those are entered, these were all pre-entered. You're going to enter your part in the machine. So the notch is away from the hammer that's going to come down. And just get that as centered as possible. There's nothing that has to hold it in place. Once you close the door, should be ready to test. And that is the hardness for the impact for the polycarbonate. Again, to show a difference at why we chose the polycarbonate as opposed to the ABS for the exterior of the mug is because of its harder impact resistance. So we'll go ahead and get that up. And we have a broached ABS part. Again, notch away from the hammer. So the polycarbonate, as you see, is 130.06 joules per meter. And as you see, the difference with the ABS is 42.13 joules per meter. So there's a significant difference in the impact strength, which is why you want it for a travel mug. If you have it on, if you're just carrying it and you drop it, you don't want the exterior to break. If you are biking for some reason and you drop it at a high speed, you don't want it to break or shatter. You want to make sure that that material stays, or the fluid stays inside of that coffee mug. For the heat deflection test, that was not something actually performed in the lab due to time constraints. Instead, we looked up all of the material specifications on matweb.com, looked up the different materials we chose. Between the materials that we chose, this is for the interior, since heat deflection would be the temperature at which a material will alter its shape. So we want to make sure that when we put in the hot coffee that it does not deflect the coffee mug. So research went into the brewing temperature of coffee, which is between 93 and 96 degrees Celsius. So in order to keep that in mind, we have to find a material that has values above the higher end. When looking at that, the only two materials that we tested that were above that were nylon and PET. Now from there we went and did the moisture or water absorption test. We took materials that were preconditioned, 24 hours in water, and preconditioned inside of an oven to be fully dried. We put them on the slides per procedure to look at how many air bubbles come in the water-soaked samples versus not. From there, we determined that only PET and HDPE had the lowest water absorption. Now, before I mentioned that PET and nylon were the only two with heat deflection temperatures high enough. Water absorption for nylon is extremely high, so you ideally do not want to use that for any material that holds water, such as a travel coffee mug. So from there, we narrowed down our conclusion to use PET as the internal material for the coffee mug and polycarbonate for the external. Alright guys, we've made our way over to the tensile tester here. This is one that is approved for polymers as opposed to metals. We will be testing the polycarbonate since that was the better selection for the test as shown in the impact test. Throughout the experiment we tested both conditioned, dried, as well as being immersed in coffee for 24 hours. Since that is the chosen material, even though it wouldn't ideally come in contact with it, we wanted to see what that would do to the material itself. So we will be testing the polycarbonate at 20 inches per minute, which is one of the two approved rates from the ASTM standard. And my assistant Teddy here has a piece for me which was pre-measured and entered into the computer appropriately. Entering the component into the tensile tester, you want to make sure you have it as evenly as possible within the jaws, the same amount in the jaws. I like to hold the jaws to make sure you don't torque the part at all when it's being tightened in there. You also want to make sure you don't actually tighten the jaws too tightly. You don't want to cause a high stress area somewhere else in the part that's not intended. So you see it's securely in there, and my lovely assistant Evan McCool will be hitting the start button for your enjoyment today. Alright guys, so these are the results of our tensile test for the polycarbonate. You can see right here we have our ultimate tensile strength of just under 10 KSI. It's at 99.82 PSI. That will be the conclusion of our test. With us today, you have our equipment manager, Evan McCool, our fashion manager, Cesario Mendez, and as always, our safety manager, Teddy Piat.